Let's take a look at graphing polynomial functions. As always, plotting additional points such as x-intercept and y-intercepts will help in sketching an accurate graphs. To calculate the x-intercepts, let y be 0, and then we're going to solve or use the zero factor property to find the x value that make y to be 0. To calculate the y-intercept, we just plug in the x equals 0. So we're going to look at the example. Forget the graphs of the following polynomial functions and paying particular attention to the x-intercept, y-intercept, and the behavior as x approaches positive and negative infinity. In part A, f of x equals x squared minus 6x minus 7. Start with finding the x-intercept. That means we let y be 0. We get 0 equals x squared minus 6x minus 7. And we're going to use the 0 factor property or use the factoring technique to look for the 0x. Factor completely, we get x minus 7 times x plus 1. That tells us the zeros are x equals 7, negative 1 as x-intercept. Next, for the y-intercept, we let x be 0. So then y equals 0 minus 7 or negative 7. So we can say that we're going to have at least 3 pairs that we can plot in the xy plane right away, like 7, 0, negative 1, 0 as the x-intercept. And over here, y-intercept, when x 0, y going to be negative 7. 7, 0 right there, negative 1, 0 right there, and 0, negative 7. And for the behavior, for the leading term, x squared, that means the an equals 1. The n or the power is 2. A equals 1, that is the positive number, and n equals 2 is an even number. That means as x approaches positive infinity, the function f of x approaches positive infinity. X approaches negative infinity, the function fx approaches positive infinity as well. So this is the power 2 function. Sketch the curve passing the x-intercept, y-intercept. Let's look at another example. This function f of x equals negative x times 2x plus 1 times x minus 2. When we look at the x-intercept, let y be 0. So 0 equals negative x times 2x plus 1 times x minus 2. We got 3 zeros. X equals 0 from the first factor. X equals negative 1/2 from the second one, and x equals 2. Therefore, we have 3 x-intercepts. 0, 0, negative 1/2, 0, and 2, 0. For the y-intercept, let x be 0. We got y equals negative times 0, 2 times 0 plus 1, and 0 minus 2. 0 times anything, we get 0. And we obtain the point 0, 0 or the origin as another y-intercept. For the behavior of the graph, we're going to look at the leading term. For the leading term, we just do the quick way by multiplying the x. I'm going to put a note here. The leading term is derived from negative x multiplied by 2x multiplied by x which is negative 2 times x to the third. That tells us the an is negative 2, the n equals 3. An negative 2, which is negative number, n equals 3 is the odd number. If n is odd and an negative, we look at the behavior that's similar to the graph of y equals negative x, which is the graph that's falling down. So we can say that the behavior as x approaches negative infinity, the function f of x approaches positive infinity. X approaches positive infinity or the right end, the function approaches negative infinity. Starting with plotting the x and y intercepts on the xy plane. 0, 0, negative 1/2, 0, very tight here, and 2, 0, and the behavior gonna be the polynomial degree 3. Maybe something like this. That's a sketch.